Static analysis, there are basically these six steps. One is the engineering data, and in the engineering data, there is a structural steel which is a default material in ANSYS software. So in the here you can see the density is available, then Young's modulus is available. So different material properties of this structural steels are already available in the software. Now we will consider this structural steel as a default material. Then we'll go to the geometry. Before that, we can just right click here and we can import new geometry. So right now we have just drawn one cantilever beam in CATIA software. On the desktop, you can see part1.igs. It is saved here. Okay. If you open here, it will take some time to get imported in the software. You just double click on the model, you will see the file. So this type of window will be there. Here we will apply load on the component. Before that, meshing will be done on that cantilever beam. That means we are going to divide that cantilever beam into number of components, sorry, number of parts, and these parts are called as a elements. So here we can see this is a cantilever beam which was drawn in KDS software. You can draw in SolidWorks also, but save it in .igs format. Now go to the mesh, right click and generate mesh. So this component will be divided into small pieces. These small pieces are called as elements. Just click on this side and just right click over here, insert fixed support that we can. So first of all, you click on static structural, then click here and you can select here fixed support. Okay. So we are going to fix this beam at one end. And similarly, we will apply the load on this portion. Okay. On this portion, we are going to apply the load in the downward direction. If you want to apply the load axial, you can apply in this page axial. So I will apply in the downward direction. Insert. There is option force. So here we will select the component. There is a sub option component, and we will apply suppose minus 1000 Newton. So in the downward direction, y direction, there is minus 1000 Newton force output. And just right click on this one, solve. So it will take few minutes only because this component is very simple in geometry. It's not complicated. Okay. We will see the displacement at the end, displacement over here, then stresses generated in the component. So here all green ticks you can observe. Now solution is completed. Just right click over here and click on the deformation. You will see the total deformation in the component and just retrieve the result. So you will see the deformation in this program. And you can play the animation how it works. So maximum deformation 0.0014 meter and minimum is 0. It is fixed over here. So how the load is acting on the component, you can see how it behaves. Okay. So this is simply about deformation. You can see a maximum stress that is called as a 1 minus stress enhances soccer. So 7.9 into 10 raised to 7 Pascal. This is the unit. That is the maximum stress. And you can see maximum stress is acting over on this reference. Then you can see another, suppose the deformation at the tip. So for this purpose, what we have to do, you have to click here on element. There is one option, and you have to select the element on the surfaces here at this area. On this portion because here load is applied. So we are selecting some elements, not fixed, some elements we are selecting, and here we want to see stress value or the deformation value. You can see the stress value or deformation value in this way. So you can see on this portion, the maximum stress value you can see deformation value is 0.0014 meter. It is negligible deformation. You convert it into mm, it will be hardly 0.14 mm maximum. Are you getting? So in this way you can calculate. Now for the journal purpose, what we require. So first of all, you have to see its geometry. This is geometry. So cantilever beam, and you have to capture this image, and we have to take this printout and paste it into the journal. So for this purpose, so you go to home, then you click on print preview. So you will see this image, and you can take its a snapshot, or you can save it as a PDF or high extended image. You can save, and we will send it to Microsoft Word or PowerPoint. Are you getting? If I send it to PowerPoint, that image will be opened in the PowerPoint. Are you getting? So likewise, we have to collect different images. The first image. Are you getting? So likewise, we have to see the different result images. Now total deformation image. So this is a total deformation image. Are you getting? Here there is a value of total deformation. If we can send that to the PowerPoint again. Are you getting? So such results we have to get take into PowerPoint, and then we will take its printout. Then similarly, we will see the result of this one, equivalent stress here. This is what equivalent stress one. Okay. So some results are, I think, not visible properly. You will adjust the geometry. Here is the equivalent result. And we can click on here, print a preview. Okay. And once again, we will send it to PowerPoint. Then the total deformation also we can see here on tip of the beam. Likewise, you can calculate the deformation on this region also. You can select. Alright. The same method you have to apply, and you will send it to PowerPoint. Okay. So here in this way, we have gathered here four results. Just you adjust these results properly on the PPT, and then you can go for the taking its print out. Okay. Hmm? In this way, you can go ahead with the print out. Or you can adjust four images in one slide, and you can take only one print. That also you can do, which is more comfortable to you. You can already. If you take here one image, you can insert one table, and you can take here four images. That will give you an answer. Already. Now I have taken in this way. Okay. Now this is what about the result. Now what we have to do? We have to generate one report of the analysis. So how we can do? So here there is option report preview. So here report preview or complete analysis report will be generated over here. What things are there? How many elements are there? Are you getting? In what condition analysis is carried out? So we have to send this report in Microsoft Word, or you can send it to PDF also. The print option is there now. So you can take it to the PDF also. You getting? So I will save this report in PDF, because that is most suitable for explaining the results. You getting? I will save report of analysis. So this is simple static analysis. Static analysis report. In this way, report is generated. Now, at the last, what is to be done, that I will tell you, which will make your task more simple.